Welcome to an example on how to use Desmos to perform linear regression and also how to use Desmos to make a prediction using the line of best fit. The following is data for the first and second quiz scores for 8 students in a class. We want to use the data to determine the line of best fit, plot the points on the coordinate plane, graph the line of best fit over the data, and then finally use the line of best fit to predict the second quiz score if a student scores a 40 on the first quiz, and we're asked to round to the nearest whole number. So the first step is to go to desmos.com and launch the calculator. So here's desmos.com. We want to click on this red button to launch the calculator. Next, we want to enter the data, and there are two ways to do this. To enter the data by hand, we would click Add Item and select the table. But if the data is in Excel, in our case in MathAS, we can simply copy and paste all the data in one step. To do this, we go to our question or Excel and we copy the data. So we select the data in the table here, and notice how we can include the column titles as well. To copy this, we press Control C, or if we want, right click and select copy. We go back to Desmos, click in this first cell, and paste the table here by pressing Control V. Notice how once we do this, the table shows up and the points have already been plotted on the coordinate plane here on the right, and the axes have already been scaled appropriately. If we want to change the color of the points, we can do that as well by clicking Edit List, Y1, and then select the color that we want. Let's select red. And then we click Done. Notice how now the points are red. Now we can perform linear regression. To do this, we click Add Item and select f of x expression. And because we have x sub 1 and y sub 1, we want to enter y sub 1 as y1. And then for regressed against, we use the twiddle, which is shift apostrophe from the keyboard, and then m times x sub 1 plus b. So m x1 plus b. And notice when we enter this, the linear regression is already performed, where the slope is 0.858 and b, the vertical intercept, is 2.1. Notice how we're also given the correlation coefficient, which is 0.987. Because this is close to positive 1, we know this linear equation is a good fit for the data, and the line has a positive slope. Notice how it also provides the residuals, which we can plot by clicking this button here. The residuals are the difference between the y values from the table and the y values from the line of best fit. Because we're asked to graph this line of best fit on the coordinate plane, if the cursor is in y1, if we move the mouse over the vertical intercept, it gives us the coordinates of 0, 2.1. It also gives us the horizontal intercept of negative 2.44, 0. If we click anywhere else on the orange line, the coordinates appear, so we can use any other point on the line of best fit to help us graph this on the coordinate plane. For example, we could use this point here with coordinates 30, 27.84 to help us graph the line of best fit on our own coordinate plane. Now let's make the prediction for the second quiz score when the first quiz score is 40. To do this, we'll go back up to Add Item and select f of x expression, and we'll enter the equation for the line of best fit, which is y equals 0.858 times x plus 2.1. Now from here, we're going to go back up to Edit List, and then for the equation that we just entered, we're going to click here to convert to a table. Once a table appears, using our line of best fit, we can enter any x value, and the corresponding y value or output will show in the table. So we'll go to the first row, delete negative 2, and enter 40 for x, and notice how the y value, our second quiz score, would be approximately 36.42. Running to the nearest whole number, we'd predict the second quiz score to be 36. So now going back to our question, remember we have a line of best fit of y equals 0.858x plus 2.1. Now the question does ask to plot the points on the coordinate plane, which I've already done. Next, we're going to sketch the line of best fit over the data. To do this in MathAS, we first select the line tool here, then we click on one point on the line. Let's use the vertical intercept, which would be 0, 2.1, which would be approximately here. Then we click on the second point, and remember we found from Desmos we could use the second point with coordinates 30, 27.84. So 30, 27.84 would be approximately here, and therefore the line of best fit would pass through these 2 points. Let's also graph this line in MathAS. So we first select the line tool, then we'll click on the vertical intercept of 2.1, approximately here. Of course, we can use any 2 points on our line, but this is a convenient one to use. And the second point that we found was 30, 27.84, which would be approximately here. So single click for the first point, single click for the second point. To make any adjustments, notice how if we move the mouse over one of the points, this double arrow appears, and we can adjust the line as needed. And finally, for the last question, it says use the line of best fit to predict the second quiz score if a student scores a 40 on the first quiz. And again, going back to Desmos, we already determined we would predict the second quiz score to be 36 to the nearest whole number. So the second quiz score is predicted to be 36. I hope you found this helpful.